Well, hello once again, and this is John Byrne doing another little video, just looking at resistance and resistivity. And one of the questions that's come up on some practice questions was to do with having material that was maybe had certain dimensions, something like that. And I think it was something like 4 centimeters that way, and about 0.6 centimeters this way, and a height of 0.8 centimeters that way. And the question was asking about what sort of dimensions, when you measured resistance across two different faces, whichever they were, or as it were, then what dimensions would give the minimum resistance. So we want to work out what's going to give the minimum resistance. Okay, and so from the formula for resistivity, we've got resistance is resistivity times the length of the material divided by the cross-sectional area, and the cross-sectional area in this case might be just a square, so that's fairly straightforward. Alright, so if it's uniform resistivity all the way along, then rho resistivity is going to be a constant, and what that means is we can take that out and we see that resistance is proportional to length over area. Alright, so the longer the material, the bigger the resistivity, and the bigger the cross-sectional area, then the smaller the resistance. I should have said resistance there. Yep, so length is proportional to resistance. So if we want to know what the minimum resistance is, we want to measure across what is going to be the shortest length. And so we've got 4 centimeters that way, 0.6 of a centimeter that way, and 0.8 of a centimeter that way. So I've drawn this a little bit not to scale, but never mind. And so to give us the shortest length would be across, would it be across 0.6? So we're kind of going to measure, how would you draw that? We're going to need to measure somehow across that 0.6 sort of length. So we'd connect a lead to that side, and we connect a lead to that side at 0.6 centimeters. Okay, so that's going to be our length, and then our area would be this bit. That's our cross-section area, and that's going to be the 4 centimeters along here, and also the 0.8 centimeters over there. So 0.8 centimeters times the 4 centimeters. Okay, and then we'll shove those numbers in. So that's how we think about it. That's going to give us our minimum resistance because it's got our minimum length, and therefore that'll give us our minimum resistance. Okay, so I'm not going to do it all for you. For those who are studying that question, one extra thing just to remember is that these are centimeters and centimeters, and resistivity is very often measured in ohm meters, and because of that meters, we need to convert all of these into meters. And 1 centimeter, the way I remember it, is 1 centimeter equals 1 times 10 to the minus 2 meters. So if I'm multiplying these two together, it'd be 0.8. Let's just try and make that a little bit clearer. The area in this case might be 0.8 times 10 to the minus 2. So that's the centimeters bit, times the 4.0 times 10 to the, we're still on there, minus 2. Shove that in your calculator and you'll get an answer in meters squared. Okay, we'll also need to convert that 0.6 into meters too. 0.6 times 10 to the minus 2. Okay, before you can put it into this part of the formula to work out that minimum resistance. Last part of the question was, once you've worked out that minimum resistance equals however many ohms, we then were told that we're given a voltage of about 0.0. Let's just check, yeah, 5 volts. And so to work out the maximum current, well, for the maximum current we want the minimum resistance. We've just worked that out. That's going to be voltage over resistance. So it'll be 0.05 divided by whatever answer you got before. We'll give you an answer in amps. All right, I hope some of that is helpful in thinking about how to approach that question. Best of luck.